Number 1. The Big Rip. It was long the scientific consensus that gravity would inevitably break the universe's expansion. However, a shocking surprise emerged in the late 1990s. The universe's expansion is accelerating. Behind this acceleration lies a mysterious, unknown force called dark energy. The Big Rip theory poses a terrifying question. What if this enigmatic energy continues to escalate, becoming stronger and stronger? Imagine the fabric of space-time as a piece of cloth being constantly pulled from every side with ever-increasing force. In the initial stages, galaxies drift apart at incredible speeds, leaving our galaxy, the Milky Way, isolated and alone in a cosmic sea of nothingness. But the catastrophic climax begins when that immense accelerating force overcomes the fundamental forces that bind matter together. The galaxies will be the first to be ripped apart, followed by the solar system. Earth will be instantly wrenched from its orbit around the Sun. After that, the pulling force will become stronger than the gravity holding our planet together, and it will be torn into countless fragments. Finally, it will be our turn. In the final split-second moment before the end, the tearing force will exceed even the bonds holding the atoms of our bodies together. Everything, from the vast cosmic structures to the smallest elementary particles, will be crushed and annihilated. It won't merely be the end of life, it will be the nullification of matter's very existence. Number 2. The heat-death theory. In 1854, while the world was pursuing the Industrial Revolution, the German physicist Rudolf Clausius introduced a concept that was simple yet terrifying: entropy, or the inevitable increase of cosmic disorder. This law, known as thermodynamics, posits an ultimate end for everything, referred to as the heat death. Imagine the universe as a massive mechanism that began with a tightly wound spring slowly releasing its energy. Stars, including our Sun, are merely fires consuming this cosmic fuel, but this burning is not eternal. The essence of this end is not in a violent explosion, but in a gradual and tragic dimming. Stars will consume their fuel until they cool and darken, leaving the universe in an unbearable chill. Even the colossal black holes will gradually decay through Hawking radiation, releasing their last remnants of energy into dead space. The final scene is a dark, infinite expansion, a cosmic ocean where the remnants of stars and planets drift and temperatures approach absolute zero. There will be no available energy or organized movement, only scattered particles, hardly ever interacting. It is the perfect eternal silence, an end without drama, where the universe's fate slowly concludes in a final chapter that no one can read. Number 3. The Big Crunch, the universe reborn. The most common theory regarding the origin of the universe has always been the Big Bang. But what if the fate of the universe is a reverse-action replay of its beginning? This is the core of the Big Crunch hypothesis. Imagine a ball thrown up into the sky. It rises to its maximum height and then falls due to gravity. This theory hypothesizes that the universe acts in the same way. Since the Big Bang, it has been expanding. But there might be an enormous cosmic gravitational force resulting from dark matter and dark energy sufficient to reverse this expansion, starting to pull everything back towards a single central point. This scenario would begin with a role reversal. Instead of galaxies moving apart, they would start approaching each other, dramatically increasing the universe's heat and density. The night sky would no longer be dark, but would become luminous and scorching hot due to the collision of stars and galaxies. Temperatures would exceed billions, leading to the disintegration of atoms and the transformation of matter into a soup of elementary particles. In the final stage, every component of the universe, matter, energy, space-time, would collapse into a single, infinitely small point, yet holding all the universe's mass and energy. This is the singularity, where all known laws of physics fail. But the paradox lies in what follows. Some scientists hypothesize that this collapse may not be the absolute end. Instead, this singularity might, in turn, explode in a new Big Bang, initiating a completely new cosmic cycle. The death of our universe becomes the prelude to the birth of another. Number 4. The Multiverse and Quantum Demise. Could our universe not be unique? The idea of the multiverse suggests that our existence is merely a finite bubble within an endless cosmic ocean. In this framework, the end might not come from within our world, but from outside of it. In the context of string theory and the concept of eternal inflation, our universe is considered just a pocket within a much greater space. The immense expansion that followed the Big Bang did not stop. Rather, it continues in other places, constantly giving birth to new universes. We reside in a region where this expansion has slowed down, allowing for the formation of stars and galaxies. But what is the scenario if a flood of this ongoing inflation were to invade us? Imagine a giant cosmic wave carrying not water, but different laws of physics. By striking our universe, it would reshape the very fabric of our reality. Our world would be transformed into a region of active inflation once again, leading every particle of matter to stretch and separate at a speed that prevents the formation of celestial bodies. The result would be the transformation of our life-filled universe into an endlessly expanding void. Another possibility within the multiverse models is quantum demise. If universes are constantly being born and dying, perhaps every universe has a finite quantum age. When our universe reaches the end of this age, it might simply vanish from existence, much like a ripple disappearing into the vastness of the ocean.